For this problem, we want to take a look to try to figure out some of our logarithm properties. So we know that logarithms and exponentials are equivalent to each other. Okay, so with exponents, we have our exponent rules, right? We're going to transform those into some logarithm rules. So first of all, we have x to the power of a and x to the power of b. If they have the same base, what are we supposed to do with our exponents? We add them. So this is really like saying x of a plus b. And with division, we're subtracting. So if we have the same base again, this is like saying x to the b minus a. So we're going to look at how this translates for logarithms. Okay, so if I were to put log of 5 plus log of 6 in my calculator, I get 1.477 equals log of x. So to solve for x, I can rewrite this as an exponential. So it would actually be, so this is a base 10, it would be 10 to the power of 1.477 equals x. So I'm going to put that into my calculator. So 10 to the power of 1.477. Okay, so if you look here, we've got 29.99. So I'm going to actually round that up to 30. So 30 equals x. So I'm going to plug that back in up here. So what we're saying is log of 5 plus log of 6 equals log of 30. And if I put log of 30 in my calculator, I get that 1.477 that I had before. So these are equivalent. Well, what can I do with 5 and 6 to get to 30? I can multiply them. So when we have the same base and we're adding, we can really say it's the same as log of 5 times 6. To shorthand this. So instead of having to do all of this work of changing it into an exponential and so forth to find that, what we can really find is that if we just multiply our two numbers inside the parentheses, it will give us one simple problem, so log of 30, which will get us to that 1.477 that we were looking for in the beginning. Okay, so you're going to apply this rule moving forward. So a couple more of these problems to practice, and we'll see if this continues to work.